Tonight's lesson is on changing scales. A lot of times with train sets, train enthusiasts like the toy trains to be exact scaled down models of the actual trains. So that's what tonight's examples are about. It says Ronald received a special toy train set for his birthday. In the picture of the train on the package, the boxcar has the following dimensions. The length is 4 5/16 inches. The width is 1 1/18 inches. And the height is 1 5/8 inches. The toy boxcar that's actually inside the box has dimensions: length of 7.25 inches, width of 4.5 inches, and a height of 6.5 inches. The actual real-life boxcar is 50 feet long. Find the scale factor of the picture on the package to the train toy set, So take a minute, pause the video, try it out, come on back. All right, hopefully you paused the video. First of all, we're looking for scale factor, which means we're just looking for a unit rate. And we're looking for the picture on the package to the toy set. So we want to do picture to the toy set. So I'm going to just use the length of the picture on the package and the length of the boxcar in the toy set. You could choose to use width and height. It doesn't matter, width or height, it doesn't matter. But if you're using length for the picture, you're using length for the toy set, and so on. So it's 4 5/16 of an inch in the picture, and the boxcar length, the toy boxcar, is 17.25 inches. I'm just going to rewrite that as a mixed number, 17 1/4 inches. And to find our scale factor, our unit rate, it means per 1 inch. So what that tells us is if our toy set was 1 inch long, the boxcar was 1 inch long, how long would the picture on the box need to be? So let's just divide our denominator by 17 1/4. So we'll divide our numerator by 17 1/4. And so our actual problem we need to be solving is 4 5/16 divided by 17 1/4. 16 times 4 is 64 and 5 is 69 over 16. Divided by 4 times 17 is 68 and 1 is 69 over 4. Change that division and multiplication. So this is 69 over 16 times, flip that right over, 4 over 69. To make the multiplication a little simpler, 69 goes into 69 once, 69 goes into 69 once. Then we can multiply straight across the top, straight across the bottom. 4 over 16. I look at this and I say, okay, this is not yet in simplest form. So I'm going to go ahead and rewrite this as an equivalent ratio, but in simplest form. I'm going to divide numerator and denominator by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. That means our scale factor is 1/4. And that says to me, if my toy inside the box was just 1 inch long, the picture on the box would be 1/4 inch long. I just want to make sure you understand what this means. This means if I took the length of my toy set, which is 17 1/4, and I multiplied that by my scale factor of 1/4, I would come up with my length on the package. So if we took our toy times our scale factor, you would actually come up with the length of the picture. I just want to make sure you understand how scale factors work. So let's just double check that this really works. So my hope is if I take the length of my toy times my scale factor of 1/4, I'll come up with 4 5/16, the length of the picture. 4 times 17 is 68 and 1 is 69 over 4 times my scale factor of 1/4. That gives me 69 over 16. 16 goes into 69 4 times with 5 left over, 4 5/16. And you can see that actually is exactly what the picture ends up being. Now, if the toy times the scale factor gives me the picture, we could look at that as a division problem. Toy times scale factor gives me picture means if I took my picture divide it by my scale factor, I would get the toy. So my picture is 4 5/16. If I divide that by my scale factor of 1/4, I will get the actual toy. And we could work that out if we wanted to, and I guarantee you that will be 17 1/4 that you'd come up with. Another way to look at it is if the scale factor is 1/4, that means the picture is 1/4 the size of the toy set. Well, you could also think of that as taking the picture, and the toy set would be 4 times larger than that. So if the picture is 1/4 of the toy set is 4 times the picture. So you could also take your picture times 4 and get the length of your toy set. Okay? And dividing by 1/4 is the same as multiplying by 4. All right, now let's find the scale factor of the picture on the package to the actual boxcar. So take a minute, pause the video, come on back. We'll go through it together. All right, again, we're looking for scale factor, which we know just means unit rate per 1. And we want the picture on the package to the actual boxcar. So this time we're going to look at our picture to our actual. First of all, I have to say for the actual, they tell you the length of it, so you definitely have to work off of the length of the picture on the box. So the length of the picture on the box is 4 5/16 inches. You know with scale factor, your units must agree, so they both must be measured in inches. The problem is the boxcar is 50 feet long. We just need to go ahead and convert that to inches. Well, I know that there's 12 inches in 1 foot. How many inches in 50 feet? So we're just going to go ahead and write an equivalent ratio. 1 times what is 50? 1 times 50 is 50. So therefore I have to multiply the numerator also by 50. So 12 times 50, use your calculator if you need. That's actually 600. So the actual is 600 inches. I want to know if my actual was just 1 inch long, what teeny tiny picture would be on the package. So I'm going to divide the numerator by 600. I'm sorry, I'm going to divide the denominator by 600, which means I also need to divide the numerator by 600. So this is the actual division problem I need to work out. 4 5/16 divided by 600. 600 is the same as 600 over 1. Let's convert this to an improper. 16 times 4 is 64, and 5 is 69 over 16. Drop change, and now we'll flip this one. 1 over 600. And I'm going to just multiply straight across the top, straight across the bottom. 69 times 1 is 69. 16 times 600. Use your calculator if you need. That should be 9,600. Actually, I'm going to divide numerator and denominator by 3. Given my divisibility rules, I know 6 plus 9 is 15 because 15 is divisible by 3. 69 is divisible by 3. 9 plus 6 is 15 because 15 is divisible by 3. 9,600 is divisible by 3. 69 divided by 3 should be 23. 9,600 divided by 3 should be 3,200. And there we go. We just got our scale factor. Okay? That means that if the actual boxcar was just an inch long, the picture on the box, the length of that boxcar would be 23 out of 3/200ths of an inch. If you took an inch and you broke it into 3,200 parts and you had 23 of those 3,200 parts, that's how small, teeny tiny that picture would be. And also, I just want to remind you what scale factor means. That means that if we took our actual length of our boxcar, or width or height, and we multiplied that by 23 over 3,200, we would get the picture on the box. It also means if we took our picture on our box and divided by 23 out of 3,200, we get the actual, or you could think of that as multiplying by 3,200 over 23. You could come up with the actual. All right. let's take a look at a final example for tonight. Use these two scale factors to find the scale factor between the toy set and the actual. So what I need for you to do is I need for you to pause the video, try it out, come on back. Okay, so I know I want toy set to the actual. So that means I want the toy set to end up in my numerator, the actual to end up in my denominator. Well, if I want the actual to end up in my denominator, I'm going to go ahead and let that start in the denominator. So I'm going to do picture over actual. Then I'm going to divide that by picture over toy set. Because I know that if I then do skip, flip, multiply, drop, change, flip, toy set in the end will end up in the numerator where I want it. So this is picture over actual times toy set over picture. Picture goes into picture once, picture goes into picture once, straight across the top, straight across the bottom, and I get toy set over actual. Lots of ways to go about this, but that's how I'm going to choose to go about it. I just used some thought process of what do I need to do with what I'm given so that my toy set can be on top, my actual can be on the bottom. So that's how I worked it out. So picture over actual is 23 over 3200 divided by picture over toy set. Picture over toy set is 1/4. So then I have to do 23 over 3200. Change division to multiplication. Go ahead, flip that right over. 4 over 1, straight across the top, straight across the bottom. 23 times 4. I believe 23 times 4 is 96. Let me just double check that. 23 times 4. It's not 96. It's 92. I'm sorry about that. It's 92. Now I know I can divide numerator and denominator by 4 to go ahead and write this in simplest form. And 92 divided by 4 is 23 over 32 divided by 4 is 800. So that right there is my scale factor for toy to actual. And what that means is that the toy side, the size of the toy is 23/800ths of the actual. So if you took your actual and just multiplied that by 23/800ths, you would get the size of the toy, the length of the toy. And if you took the toy, divided by that, which is the same as multiplying by 800 over 23, and it makes sense, you're going to multiply by 800, we're going to scale it up, and then just divide by 23, you'll be able to come up with the actual. Just want to make sure you really are understanding what scale factor means and how we then use our scale factor to go from the actual to the toy or from the toy to the actual. And for your focus question tonight, I'd like you to explain, it should say in words, how to find the width and height of an actual boxcar using the scale factors we found. Now, I don't want you to do any math. I don't want you to actually find the width and the height. I just want you to explain in words, using your scale factors, how could you find the width and height of that actual boxcar? So do a nice write-up on that and be ready to share tomorrow. Thanks. Have a good